Hi everyone, and welcome to International Girls in ICT Day. I'm really excited to be here to talk about creative computer science education. In today's session, there'll be an introduction of what myself and what we're going to do. A look at terminology, the MicroBit, the MakeCode platform, and creative computing through my research. I am a second year PhD student at Cambridge University. I'm also a lecturer in digital media at Roehampton University. My particular research looks at creative computer science education in different ways to approach and teach it, and also looking at a focus on data ethics. And we do this by using biometric data from things like skeleton tracking, like you might use with the Connect, or brainwave data that we use with a particular headset called the Emotive Insight. And as you can see on screen, here is a recording of my brainwave data taken a few days ago using some visualization software. And this is all done through computing and coding. We're going to be focused on the terminology used in today's session. We have a focus on computational thinking, which involves 5 main areas of decomposition, pattern recognition, abstraction, and pattern generalization. And each one of these elements has a different purpose to help you problem solve, break down your problems into smaller parts, look for any patterns, and help you design any algorithms that you might be using in your code. We think about how we approach a problem and make it manageable for us. And this is where the decomposition comes in. So given us manageable chunks that we can break down a larger problem into smaller executable elements. And then we've got pattern recognition. So when you're doing things like a game, maybe, or a simulation that you might want to look at, or like sort of tidal information or weather information, they tend to have patterns that happen. And this is what we're looking for. So similarities and behaviors in the code or in the output that you're creating. So another really good way to look at problems, instead of thinking of this sort of, oh my God, this is too complex, is what is its most simplest form? What is the most sort of minimal elements that we can look at when we're creating our code or designing our project? And this is where abstraction happens. So this is like just the bare minimum sort of very high level detail of the problem that you're trying to approach, or the goal, because not everything's a problem. So, creating a video game doesn't seem like a problem, it's more of a goal. So, but yeah, so we have to think in both terms. And then when we come to pattern generalization, this is about the patterns that we were looking at, and can we encapsulate or make them into a block of code that we can reuse and repurpose throughout our whole program. So this is what it's looking for in that sense. And then algorithms. Okay, so an algorithm is a set of instructions or precise methods for solving any given problem or task. Yeah, so not everything, like I was saying, not everything is a problem. So for example, the kind of, you might have a mental algorithm for getting to school every day, the sort of route that you take. There might be a mental algorithm for, like, cooking or recipes. They're all kind of part of that. The one example on the board is actually about bike maintenance and the things, the processes that you would have to go through that. Algorithms are also used in decision making. So medical, you might see medical decision making using algorithm design. So we use the word algorithm not just in the field of computing, but elsewhere as well. So what we're going to look at now is the MicroBit. So while I'm talking, I'm hoping that for those who have got access to a computer are actually already online in the MakeCode platform. If not, take your time to do that now, and then we can go through it. So this is what a MicroBit looks like. It's a little microcontroller that has multiple sensors on it and allows you to program in multiple different languages, actually. So you can code it in block-based programming, you can code it in Python, and you can code it in JavaScript. And probably there is more ways to code it, but they're the languages that I teach in. So yeah, and we're going to have a look at what's available, even though we might not be able to access these because we're just using a simulation. So kind of electronic emulator of the actual microbit as opposed to the microbit itself. So on the board, you should be able to see that you've got some buttons at the front, you've got some tiny little LEDs in the center, and they're red LEDs. And the reason why they're red is because that's the least amount of power out of all of the colors that it takes to light up any LED. So if you want to reduce power consumption, then you would use a red light. And then on the back, it shows you all of the different sensors that are available. So it's got Bluetooth, it's got an accelerometer, it's got it's a 6-point accelerometer, so it can be used as a compass. It's got magnetometer, Bluetooth, lots of other different sensors that you can use in order to help you create the projects that you're looking for. And at the bottom, the sort of little circles with the metal pins are actual sensors to output. So you can help with, adding in and linking with either external sensors. You can add speakers and make your own little disco sound box. You can add other elements to it, and like motors and lots of different kind of fun things in order to make your projects a little bit more physical. So let's get on to MakeCode. So makecode.com is an online platform. And there's a really good thing for those teachers that are here. There's actually a MicroBit classroom that you can use, but it's only in beta, so it's not fully released yet. And that allows you to create a lesson for your students. They all log on, and then you get like a gallery view of everybody's student work. So you can see them live, real-time coding. And I'll send you the link after this session so you can have a look at that in your own time. But it's a really useful activity, and it allows you to keep all of your students' code in one place, which is always a good idea, I think. So this is what the platform looks like. And I'll just put it in the chat as well for you in case anyone needs it. Hopefully for those of you who are ready and logged on, we're going to start with our very first little tiny project. So we're going to do a few different projects with this, and just to build up in case you're not used to using block-based programming. So this is what it looks like, and we're going to be playing around with the functionality of what we can do with the microbit in MakeCode. So as you can see here, we've got some blocks that are on, start, and forever. So there's different ways that you can get your program to execute and run on your microbit. And as you can see here, I'm just drawing some LEDs and a smiley face, and I've got some text. So yeah, so I'm going to switch to the actual microbit platform so you can actually see what I'm trying to do. So you should be able to see my microbit here. And this is what the platform, we're just going to explain a little bit about the platform while we're going through it. So we've got our simulator here that you can see. And this allows us to execute our code and see what's going to happen, even if we don't really have one, which is very, very useful. I love that. And then we've got these different code blocks. So we're mainly working in basic for this first activity, and then we'll move along and add some more elements to it. But I'm just going to show you what's available so you can see. So these are basic functionality to get your microbit to start and to do certain little activities and tasks. So you've got show a number, so it can display an actual number on the LED matrix. Create your own picture or image using this one, or use icons, and there's several of those here. So if we just connect it, you get like a click, and then these are all of the icons that are pre-built for you. Okay. And then we've got string, so that means text, which it'll display any text that you put in between two double quotes, including whether they are capitalized or not. And that's one thing I want you to play with when you're looking at this activity, is lowercase letters don't display too well on the LED matrix, because obviously we can't get that nice curve that we would do with normal handwriting or stuff that we've done. So, and so we've got clear screen if we wanted to get rid of our images. If we want something to run forever, so it just continually plays. So if you wanted like a little kind of, if you were doing like the equivalent of a flip book and you wanted little pictures to change, you could do that. If you want something to display when you just starting it as opposed to all the time. And then this is a really important one when we're changing between different graphics, and that's the pause, and it's done in milliseconds. So we've got like 1 second, and then we've got 2 seconds and stuff. And you'll see it's because the eye can't work as fast as the computer. We actually need these pauses to see the individual images render. So you can try it without. And then as you can see here, we've got like, if you wanted to have an arrow, so you could get like use it as a compass. So you can use the actual microbit as a physical compass, and this is one of the things that you can do with it. So I want you to, when you start a new project, which you'll see if we go home. So once you've logged in, it looks like this, and we tend to just do new projects. This is what we're going to do first, and then we'll move on to one of the other step 3 tutorials so I can show you what that looks like. And then I'm just going to give it a name, hello name. And remember, it's sensible names and names that make sense, so that you can remember what you've done. So the more projects you make that you've called test, 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 you won't know which one it is. So sensible, useful, rememberable names are really important, and especially when it comes to naming variables. So yeah, so when you start a new project, you can see that it gives you these 2 blocks automatically. So on start is as soon as you kind of power up the microbit, this will happen, okay? And then the next one forever is when your microbit's powered, do this all the time, okay? So sometimes you might not want to do things all the time, but sometimes you might do. So we're just gonna have, and if you want to get rid of a block, you just drag it like this. So we're just gonna get rid of the forever. And it makes like a funny little noise as well. So you'll hear the kind of like crushing of paper and as it's going in the bin. I'm gonna show some LEDs, and then we're gonna do a little smiley face. Oh, there we go. So, and then I'm gonna add, and you can see already it comes on, we have this tool from Barbuda. So they've just joined. Hi everyone. We'll just give you a minute to set up, and I'll recap the instructions while we're all having a play. So we've, that's okay, don't worry. Just give yourself a couple of minutes to set up, and then we'll carry on, okay? Yeah. So as you can see, so I want some text. So you make sure that you're on the MicroBit editor. So the makecode microbit.org editor. And as you'll see here, we've got our little microbit, which is our simulator running, this is why I really like it, because we don't actually need a physical microbit. But if you do have one, then that's wonderful. And we'll go through with how you can set that up. So we've got on start, we've got show some text, which is string. If you have any problems, for the teachers, do put your message in the chat, and both myself and Miss Camacho, sorry, will help you sort out your technical issues. So guys, so as we're following through, so we've got this little on start, show string, show LED, and then I'm going to do show icon, just drop it in, and then I'm just going to pick my little ghosty one, and then I'm going to refresh, and then it'll do like hello, and then you can see how quick it is. So if I get rid of the string and just leave that to the side, and then we refresh, and we're going to start it again, you can see we don't get enough time with the smiley face. It just goes straight to the next one, because if you think about how programs work in computing, it's each line's executed, and this is the same as having 3 lines here. So on start, show LEDs, and show icon. It doesn't quite look like that in the code, but we're using block-based programming here because it's kind of easy, and we don't have any syntax errors, which is also a joy. So yeah, so one of the really fun things to think about is how do you want these to loop around, and this is where we have our forever block as well. So We can drag our forever block. We can put these inside here and get rid of some stuff. So this will run forever, but it might not run as you want it to. So this is some of the things I want you to think about. How can we improve this code to make it so it's actually going to kind of run the way we want it, which is like, I want to be able to see everything with a little bit of a break between them, so I get this kind of nice flowing pattern. And as you can see, if you look at the text, the kind of lowercase is a really odd one on LED matrix. So I'm going to change it to capital letters. And it's probably easier to read when we do that. Okay. So, and if you do add extra speech marks, like I have, because I wanted to show you, then you can see it actually puts them in at the top. So if you wanted to display some quotes and stuff, you can actually put extra quotes. And if you delete it and just put more than one word, it'll automatically just add that in with a space as well between it. So play around with the text. So whether it's capital or lowercase. Sometimes the lowercase looks a little bit better than the actual, sorry, uppercase looks a little bit better than the lowercase in terms of what you're going to do with your LED badge. And then if we want to improve this to be able to see everything, what we do is we go back to that basic, and then we add these little pauses in. So we might want a pause between this one and then here. And then we probably have one at the end, so it doesn't go straight to showing the actual text. So you'd probably add another one up there. And you can duplicate blocks as well. So you can do right click and duplicate, or you can do right click and delete. So that's a really cool thing about the platform as well. So it's quite easy to modify your code. So I'm going to stop this, and then I'm going to play it again so you can see the difference. You can see the lowercase letters don't look that great. And then it just really loops and loops and loops. And you might want longer pauses because they're only really short. So you can have as long as you want, really, depending on what you want to do with it. So if you don't have access to a computer, then think about what would you want to create with it, and work out how you could do that. So you can actually write the code on your mobile phone as well, but it's a little bit complicated to teach over at 1 hour, because you kind of need a little bit longer to do that. But you can download an app on your phone and actually control and code it that way as well. So actually coding on your phone is quite a tricky one because it's kind of tiny. So these are lots of different things that we can do. This is just the very first little bit of the activity. So I'm going to jump back onto, I'm going to go back to my slide deck so you can see the code a little bit better. So you should be able to see the MicroBit 101 and displaying the sort of pink and blue blocks that we're going to be using. Now this is accessing the buttons on your MicroBit. So we should be able to button A here and button B. You should be able to see on the screen that there is the blocks that we're looking at, and then I'm going to jump to the actual make code platform as well, so that we can actually see this in real time, and I'll show you what it's like because we're going to set up a new file as well. And this file that we're going to create, this little program, is going to be quite similar. So we're going to use text and little pictures again, but with this time we're going to have some button inputs. So we're going to modify how our program starts by using either the A button or the B button, or both buttons together, or even a shake as well. So these are different ways that we can use our MicroBit. Okay, so this is the file that we were looking at, and I'm going to show you how we get back to where our projects are, because I've already signed in. So we go to home here, and then you'll see that I've got lots of different projects, and there's lots more that we're going to be looking at in a minute. But to get familiar with the MakeCode, it's really good to just have a tinker. This is what I call it. It's like the playground for code. You just have a few blocks that you need to use, and then you just play around and see what you can make. It's always the best way to learn to code. It's just think of it as a playground and be playful with what you're learning. So we're going to have our next one, which is we're going to call it input name, because we're going to use our name again for the string. And we're going to have an input feature on it. So this is why I've named it like this. So there's our new code environment that we're going to set up. And at the moment, it doesn't really do anything. So let's have a look at how we can actually set this up. So you can see at the top here, we've got on button A, and I'll drag them all across so we can see them. And then on shake. And I'll just make it a little teeny bit bigger. Okay, so you can have B button or both buttons, yeah? And then you can have different actions for each one. So we could have everything running just when we press A, or we could have just our name, or then we could have some animations that we've drawn on our LED screens, and then we could have, with a different action, the little icons. So feel free to make your own version of these, and I'm just going to go through and do a very simple version showing each one of the actual options. We're going to do, first of all, we're going to do button A, and I'm going to show an icon with that. And as you can remember, with the drop down, we get to pick which one we're going to look at. I'm going to have a little guide doing some exercise, you know, well-being in the times of virtual learning. It's actually really good to move around. It's actually quite good. It's like some exercises I make my undergrads do while we're actually online, because we have long lectures. I'm not sure they appreciate it, but I still make them do it. So, and then we're going to have another button, because I think it might be quite fun to see if we can get some stuff on button B. And I'm going to type in my name, and I'm going to type it in capitals, because it actually looks better on the scroll. And then on the shake, I thought maybe a couple of LED images so that we could create like a little moving pattern. And how we do that is by dragging in the blocks. Whoops, not dragging. And then we can just have our little pattern that we might want to actually just play around with. That's just simple as that. So now, because we don't have access to a MicroBit at the moment as a whole group, I know some of you do, we even if we do have a MicroBit in my own classroom, we always test it on the simulator first, because if it doesn't turn out the way you want it to, it's much faster to change it on in the environment than downloading it, moving the file across, and then actually test it on the MicroBit itself. So as you can see here, when we use the onShake function, it gives you a little button here to test it. So we can go shake, and it gives you this. Yeah, because each time I press it, it's going to run a couple of times. If I wanted it to do a little bit more, I'd add like a loop in there and get it to display like in a sense, a little animation, and that's where loops are really good for that. Okay, and then I'm going to press button A. We just press it. It doesn't do anything other than display it. So I haven't asked it to clear the screen. I haven't asked it to animate. So it'll just display and stay on. And then we've got button B, and then it's got my name, which takes ages. So we'll be here forever, which is a really good one, because like it gives you thinking time, which is always good. So for those of you with the computers, I really want you to have a go at doing something like this. If you don't want to use any of the buttons, that's absolutely fine. You can do what we did earlier, which was using the on start or the forever blocks. So I'm just going to give you a couple of minutes to have a go at creating your own for those who are on the computer. And then while we're doing that, I'm just going to explain how we would download it. So when you have your code, it automatically saves online in this platform area. But if you want to download it, it actually downloads it as something called a hex file. And you just download, and then you get this little message. So what you do is you connect your MicroBit to your computer with your USB cable, and then it pops up on your computer as like a little external pen drive. And it's whatever your MicroBit's called. They tend to just have like weird, odd names, but you'll see it in your list of external devices, most likely on the E or D drive, depending on what your laptop or your computer is. And then all you do is literally just drag it as if you were transferring a file. It's very, very easy. And then once you're, because your MicroBit's connected, it'll flash like a little orange light really, really fast, because it's actually transferring the code onto the little chip of the MicroBit. And then once that stops, it'll just start, unless you've done something like we have, and then it won't auto start because it actually requires an input. So once the orange light starts flashing and your code is like ours, where it requires you to press a button or to shake it, then you will need to do that action in order to test your code. It's just something worth remembering, because you go, oh yeah, but I uploaded it, nothing happens. I'm like, oh yeah, I coded it, so nothing happens until I did something with it. So yeah. And then if we just do that again, so I just want to show you another thing. So this per device one is for when you're coding like with your phone and things like that, because it's using a Bluetooth to send the code across it. So that's something that you can have a look at. It just takes a while to do that, and I don't teach it like that, because not everybody's got the same phone, and that can be a little bit tricky to try and teach when you've got different types of devices. So yeah, so we've had a look at some inputs, and it's important to think about kind of what can we do with it. And there's loads and loads. So I've used it as a data logger. So I've attached it to my ankle, and we've recorded data on it, because that was really fun. We've attached little tiny speakers to it. Terrible, awful speakers. Those little ones that you get out of like kids' toys. And get it to play sounds and things like that. And then we've added loads and loads and loads of LEDs, because I love LEDs, to do these light up installations that react to sound. So you've got your own disco lights going. And Christmas jumpers. It was the other one that we did. That was quite fun. But again, one of the really good things about it is that you can actually create your own little kind of fun interactive game. So what we're going to look at creating is actually rock, paper, scissors. And we've done some other activities where we turned it into a Morse code, and the list is endless in what you can do, and a lot of the activities are actually already tutorials on the platform, and that's one thing that we're going to have a look at. So I'm just going to share my screen. So you should see on the screen it says rock, paper, scissors. I think we all know how to play rock, paper, scissors. Might have variants of how we play it. But we're going to be looking at how to make this using the MicroBit. So one of the really good things is this activity uses lots of computational thinking. And normally in the classroom, I would get you to write down, like, what are the game mechanics of rock, paper, scissors? What are the elements that we need to understand how this game works? So what are the rules? What items do we need, like, with our hands, etc. So we talk about those different artifacts that we need in order to get the game to work. And then we look at, like, okay, so what patterns are we making? And how are we going to design our algorithm in order to get it to play rock, paper, scissors like we do as humans? So there's those different elements that we can look at and how they play into our understanding of computing. And then for you lovely teachers, when you teach the higher level, you can actually do this. Sorry guys, I know you're year 9s, but I always like to throw in some stuff for the teachers. You can actually do this with truth tables if you actually teach at that level. So, and that's a really nice activity. but yeah, so one of the really cool things is when you're learning and using new platforms like this, they don't, not only are you trying to code, but you're actually trying to use another platform. So there's that kind of like quite a lot of different elements to think about at the same time, which is why I chose this particular activity, is that in the MicroBit platform here on MakeCode, there is loads and loads of different tutorials that you can use. And they've got like coin flippers, hot potatoes, and whatever. So, but also there's rock, paper, scissors, and I love this. I do love. And then you can see here you've got the tutorial. You can just play the videos. And for those of you doing text-based coding later on, you can actually use these two. But we always start with block-based programming, and it's a really good way to get you to think about the logic of a problem without having to worry about what the syntax of the code is. And we tend to make lots of like tiny little annoying mistakes when we're coding. So I code a lot in Python with my students in JavaScript, and it's things like, semicolons and tab spaces in Python and stuff. So we all make silly mistakes, including me, all the time. So and this is a really good way just to think of the logic behind it and actually getting our design correct. So the rock, paper, scissors actually uses the accelerometer, the kind of shake function, because actually that's what's happening. It's understanding where the tilt of the actual device is in order to act like a sort of action. So when you do shake, 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 and then do whatever you're going to do with your hands. So you're doing the same thing with your scissors or however you do your actions. And that's one of the things I really like, because it's actually giving you that same physicality that you would do when you were actually playing the game. So, and you can see on here, it actually tells you exactly which block to pick. It also reduces the amount of options on the actual components that you can do on here, just for the tutorial, just to simplify it. And so you're only focusing on the bits that you need in order to create the game. So add the on-shape block. So we go, okay, I've got to add. Can you see it's only got one block that you need to do? So we do, and then we're going to go next. And then we need to do set time. So now we have to create a variable. So while we're all talking about this, I'm just going to do a little bit about a variable. Bear with me a sec. Hopefully it's jumped over to the new share. So we've done a lot of these different parts to think about how we're going to start our game. And then we're looking at what a variable is. So with a variable, it is a sort of container for some information that we want to store and use later on. And obviously, because the variable that we are changing is our actual hand. So I'm going to name mine hand. But you could use it in it. You could use anything as long as the name kind of makes sense. So first of all, the process of what we're doing is that we need to display. So we need to go to variable, and then we need to make one, and then we name it, and then we start using it. So just going to go back to the make code. Okay, so we're going to do make a variable, and then we're going to set the variable, because what we've got is 3 different states. We've got rock, paper, and scissors. There are 3 different states, and we have to assign different images to those states, and then we have to make them random because the actual MicroBit can't think for itself. So we have to tell it to do stuff. It's not a supercomputer, it's just a little tiny block. So we have to kind of, whereas we'd be thinking, oh, which one are we going to do, which one are we going to do, that kind of random element is what we're going to be doing. So, okay, so what we need to do is go to variable, make a variable, and then we name it. Oops, variables are generally lowercase. And then we set our hand to 0, okay? So we've done our first little bit of, we've stored our variable. It's not really going to do much at the moment because actually we're just setting up the functionality to get this game to work. And what it's going to do, it's going to pick a random number between 1 and 3, And 1 might represent rocks, 2 might represent scissors, and 3 might represent paper. Doesn't really matter which order. And then then it will randomly display the actual image that you want. So we can look at, so now we need to know that we need to go into maths and pick this random something to something, and it has to go into this little block here. So we go to math, and then we drop it down, and it clicks in. Now we don't have 10 options, we only have 3, even though, so we just do pick between 1 and 3. And then this is so this is where we go. So you think of the logic of the game. If 1 is picked, display rock. If 2 is picked, display paper. If 3 is picked, display scissors. And that's the sort of logic of what's going on. And this is what we're doing here. So we need to pick this if block, and then we need to add in some other blocks underneath it to get it to work. Because we're adding in multiple layers. So if hand is equal to whatever number we want, then do this, okay? So this is why the tutorial is really good, so you can actually see what the code looks like. So we go to logic, and then we do if true, and then you can see here that we're looking for the sort of the triangular box like that with 2 numbers, and then a little equals with a little drop down arrow on it. So we've got this one here, and then it's if the hand, so we go back to the variable and we drop the hand in there. You have to make it click, and sometimes it does that. Let me do this and drag it back. It's always the way. Okay, so this is our first start to our if function. So if it equals, and then you can see that it's getting us to work out number 1. So we need to change this to number 1. And then we're going to do show LEDs, and it's recommending that we do paper. Now, some people do paper in different ways. So we just do show LEDs. So I'm going to follow the way that they've done it, so that we just do a square like this. Oops. Some people just fill in the whole thing, so the whole thing goes red. Okay, so we've done that. And then, so we know now that if we shake it and the random number is picked as 1, it'll display our paper. But we don't know which random number it's going to pick because it's actually got a random function here. Okay. And then if we click it, it's just going to show it, yeah. And then the next thing we need to do is keep adding this, because we need to add now the rock and the paper, so the rock and the scissors, in order to get these extra bits. And we're going to do a sort of similar thing to it. And then we add the else button, and then we're going to show some LEDs again. And this is where I'm not very good at drawing scissors. So, see, look, told you can't draw for toughy with these things. Doesn't quite look like scissors, sorry guys. Looks like a very weird K, but you know what I mean. Okay, so we've got it to show like our paper and our scissors. And the next thing we need to do is actually add another one which pushes it up above it. Okay, so then we have like an if, an else if, and then just the last one, which is just else. So it's a little bit complicated, this one, but it does it all for you. So then we know that if hand equals 2, so we need to do a similar block to this one. So we go to the logic block and drop it in, and then back to our variable, because we want our hand again because it's on our shake. Naughty, naughty. And then you could have that as actually associated to 3, so or 2, whichever you want. So we're just going to do 2 just so it actually follows logically. And then we've got our rock. Right, so this is oopsie. So I need to get rid of my little block into the correct bit. And then I don't really, so rock, Let's just do it like this. Not quite a rock, it's more of a sort of pebble-ish. I don't know. I'm not very good at showing rocks. But yeah, so we know that they're very different images to do this. So we've got our hand is equal to 2. And then it doesn't need 3 because there's only the last option doesn't need to be shown. It'll automatically know that that's associated with actual 3. So this is, I'm just going to zoom it out a little bit just so we can see it all on our thing and we can go through. So what we've done is we've taken the shape function and then we've stored images associated with the numbers 1, 2, and 3. And we let the sort of computer decide which number it's going to pick between 1, 2, and 3. And so this is where we go, if 1 is picked, display this. If 2 is picked, display rock. If 3 is picked, then display scissors. So yeah. So one of the other good things when you're writing code is to sort of write down comments that help you remember. So for example, on this one, I can right click on the block because it's outlined in yellow, it'll attach to this one. And then I can just move it over here and call this one rock. And then so that I'm making sure that I'm not, I know, so that we can make sure that we know what we're talking about for each one. And then comments. So comments are really good for explaining how your code works, especially if you're halfway through writing something. So it's quite useful to help you remember what you wanted to do, what other code that you wanted to work with, especially when you're doing something in more than one lesson. It's really important to use your code to help you think about your planning. So I do that all the time. So I tend to write comments for the structure of my code. So when I come back to it the following week, I remember kind of what I was trying to do, and that will help me keep going and build on the code that I've done over previous weeks. And especially if you're working in pairs. So we tend to work in pairs when we're coding. And that's quite a useful way so everybody knows what's going on, even though you might not have any code in it, in that little comment section. So you might just have this added in and with no image on it, just because you ran out of time or something like that. So adding comments are really quite helpful for that. And I'll show you another way that I use comments just for you teachers. Is I would actually just write a comment and have the instructions in a separate comment that's not attached like that. And that has the instructions of what you want them to do for the code. So it's actually quite a useful way to have a look at it. So let's have a look what happens. So I'm going to test it. And I've got rock. And then if I shake again, it's got paper, scissors, rock. So if you download it, then you can actually try this out on one of your actual MicroBits. So you plug it in, write the code, obviously make sure that you've saved it and things like that. So, and you can test it as you go along. So the next bit is we're going through and making sure that we've got everything in our else block. So this is what they do for a rock. You can do it in different ways. Yeah. So that's not a problem. And again, you can get this to interact as well. So you could make it more complex, this particular project, by adding in a secondary microbit. And you could get that to work on actually working with buttons instead. So there's lots of different ways where you can get it to more complex programming for your actual microbit. So what you do, so this is what they look like when you've got a battery pack attached to it, but you can leave it connected to your computer. So you just click on the download for those. I know not everyone has this, but I'm just going to quickly go through it again. It takes a second or two just to make sure it downloads. So you make sure that your microbit is connected to your computer. And you'll see it's at the very top, the little plug, and then it'll download a file which is called a hex file, so a .hex, and it'll be the name that you called your project. So ours would be, so this would be called rock, paper, scissors. So if you downloaded a lot of them, you should be able to find it. And then you drag that onto your MicroBit that's plugged into your computer as an external drive. So it'll be in your E or D drive, dependent on where it looks. So that's, and so because obviously we finished that, so we can do finish. And then it just automatically goes into our project. If you wanted, and as you can see, the name is at the bottom here of your project, and you can save that. If you added more elements to it, you might call it like version 2 or other different types of suitable names are really, really important for those. So I'm going to give you a few minutes to carry on for those of you who are actually coding. And then I want to talk to you in the last sort of 10 minutes about some of the more crazy stuff I'm doing with coding, but I'm doing it all online with my students. So I'll just give you a few minutes and then I'll just show you what I'm doing. So I'm just going to stop sharing and go back to the slide deck for a second. And so, because I code in multiple different languages, it's quite useful to think about how you can engage and think about the possibilities, even though you might not be in the same space. So like so for example, for the mobile app course I do with my students, we use a platform called Appshed. Really nice, simple, sort of draggy droppy, a bit like this, but also if you want to do code, you can go down that route. But we built a remote control car, both here, and the company's based in South Africa, in Johannesburg, and we controlled their car and they controlled our car through a mobile app that we created, and then also we built the little board and coded it. It took quite a while to do, but it just shows you that you actually don't need to be in the same space to create and interact with code. This is one of the really exciting things. Like I'm here in Cambridge and you guys are there in the Caribbean. And you can still be in the same room. It just happens to be a digital room. So really cool stuff for the creative side of this is just one of many possibilities you can do with the MicroBit. But I want to show you something that I'm doing now. So I use machine learning as a way to capture biometric data of people. So think about like the Connect, where it captures your skeleton and stuff. So we're using similar stuff to that. And then we code it to make it do different things. So there's two different ways that we're using machine learning in my research. One is to capture all of the sort of Connect style data and turn that into actual data that we can use and create 3D avatars. So we're creating an augmented reality experience of people's data and their brainwave data. And one of the languages that we're using for this is a JavaScript language with an element called as p5.js. Hopefully you can see this. I'm just going to have to go and move so you can see my whole body. So this is real-time skeleton tracking. So hopefully you can see it. And then what you can see is like some of the errors happen when you sort of spin around. It doesn't quite get you. But yeah, so you can do loads of things with it. And it's just real time changing, which is super exciting, I always think. And this is live data that captures some of your facials, and it can also capture some of your fingers. When you add that in, you need to add some extra bit of code to get the actual finger joints. So most of the time it does your face and your actual main joints the same way as a Connect would do. There's so many different possibilities with code. And the other thing that I use is this device. So this device here is just charging, which is why I can't use it. And it's called a Motive headset. And this records my brainwaves. And it just turns it into, it has like a very kind of techie kind of format, but actually for when we're teaching and creating data visualizations, we actually just use the spreadsheet. It turns it into a comma separated value, so just a CSV file. And you can do anything with that. So what we're doing with that is creating a bit like this, the one I just showed you, the data art, and also music. You can actually code music in a couple of different ways. One of them is using the Sonic Pi. I tend to code it in Python because that's the language that we use at our university. So you can code music with your brainwave data. It's so exciting. So don't be limited just by what you can create right now. You can learn. So these are skills that I've had to learn. I didn't know much about machine learning and AI 2 years ago. I've just, I'm currently I've actually just passed my AI fundamentals exam. So there's loads of different things that you can do in order to make the possibilities. It'll just take a little bit more time. And I would hope that you can have fun with the Make Code platform, because there's lots of possibilities that you can do with that. So that we come to the end of the session, I just really wanted to sort of say thank you. And if you have any questions, feel free to fire them at me.
Well, while they get their questions together, Genevieve, I just wanted to make a comment at how exciting this seems. I'm not necessarily someone that's ICT savvy. I'm still learning a whole lot, and just seeing all that is possible. I'm so excited. I'm looking at seeing the nice little messages going across. I'm like, wow, I can actually do this,
Yeah, I know. And that's the thing about the sort of a creative approach to computing. And I know sometimes that's quite difficult in the classroom with the curriculums and the sort of mandates that we have. But yeah, so that kind of not being sort of limited, and actually computing, it can be really complex, but actually it's not about that. It's about the possibilities and the kind of ideas that you have. You can learn the skills as you go along, because I'm still learning now. And I'm 46, so you never stop learning. That's the really cool thing about technology, is that even though something might not be physically possible now in the ideas that you have, that technology is so fast in its development that it will be eventually. So yeah, we just have to be careful where it's going. That's the thing.
So the possibilities are endless.
Yes, yeah. And also the other good thing to think about is how collaborative it is. So one of the things that we certainly when I'm teaching, even in the sort of primary outreach that we do, we always work together on projects. It's always in mini groups or in pairs, because that's it's about sharing your ideas and working with other people to be soundboarding when you're stuck. So that's really quite important. And coding or software engineering or computer science, whatever, it isn't a solitary activity. It is always done in teams. So that's another thing to remember. It isn't the sort of what the sort of stereotype that we have. There's so many different possibilities and worlds that you can go into, from space technology to biomedical engineering, to data art, to finance, to weather, environment, to any industry is touched by computing. So it's like whatever you're interested in, there'll always be some way that you can bring these skills in.
Before you move on, Mrs. Commercial, before you move on, I just want to say, Genevieve, that I sat here and was following your presentation as well, and I felt so inspired. I went to your website, the makecode.microbit.com, and I immediately tried out some of the things that you were saying just now, and I found it very easy to follow. So, one of the things I want to say to our students is that you can also go on our website and, try out a couple of things for yourself. You have a tutorial as well that can walk you through what you need to get done. So it was very inspirational and very easy to follow, I find.
Yeah. Yeah, I know it's so good. It's so good. And it is easy. And as I was saying earlier, I'll send the link to the classroom one, because what the MicroBit classroom does is it creates a shared file that, like, the sort of working documents for your code, and then all the students connect into it, and then you get a live access to all your students. So from a teaching perspective, in a computing classroom, trying to see all the screens can be a bit of a nightmare. So it's really quite cool for that. So.
Okay, we have a question. I think Team Barbuda would like to ask a question. Please go ahead.
Are all the programs somewhat connected?
Are they connected? Do you mean like each one, are they linked together? No, they're not directly linked, but they might be skills-based sort of progression. But actually, to be honest, then even then, depending on how you want to do it, so you could just do random ones as you wish, which is also really good. Just dipping in and having a go is really good. So they're not interconnected in that sense, but some projects they might recommend on the tutorial that you do one first and then another, or they give you examples of other projects that are linked to them. So they're kind of they're indirectly linked in that sense, but you don't have to do everything. It's more of here's some stuff for you. This massive bucket of stuff. Just pick one out and have a go. Cool. So yeah, so we're coming to the end of the session because I'm going to have to say. Oh yeah, go ahead.
Can this program be taken off of the internet and done personally?
Yes. So there's so you can code it on an app on your phone as well. So there's a MicroBit app. There is an offline